gave us change in temperature.
19.4.
And then they gave us specific heat, and they gave us milligrams, which we'll have to convert to grams.
And we want to do that before we
Yes.
start the whole thing. Okay.
Yeah.
So we do
Is it 428?
634.0
634.0.
milligrams. Name what?
Mm-hmm. One by the SI unit guy. What is milli?
10 to the negative? No.
Mm-hmm.
Third. Yeah.
Yeah. So we'll do that.
Okay. And then you don't, so you just multiply.
Mm-hmm.
And I remember we did this before. When you flip it, it becomes positive, so it just becomes a bigger number. So you add 3 zeros.
Well, it would be divided by a bigger number.
Oh. So it becomes a smaller number.
Mm-hmm.
So it becomes 0.634.
Mm-hmm.
grams. Okay.
Yeah, so it's like 634 divided by 1,000, or times by 0.001.
And then after. And then since milligrams is a smaller unit than grams, then
It's going to be a small number.
so it's gonna be
A smaller number.
Okay. Okay. I think yeah. Okay. That's a good. I just like realized that's a good way to check your
Mm-hmm.
kind of check your answer. You know.
Yeah, that's always smart. So what's C?
C is 0.235 joules.
Joules over the grams times by Kelvin.
Uh-huh.
Okay, and then degrees Celsius.
The change is 19.4.
So we can see that we're going to find joules because Kelvin divided by Kelvin is 1. Grams divided by grams is 1. So now we just have joules. So if we times all those together, it would become grams times by that divided by grams.
Okay, that's why I couldn't do this because I didn't know like what to put in the answer. So it would be answer joules.
We're solving for heat, yes. So this answer is going to be in joules. So you just times all those out, and the answer's in joules.
Okay, let's try. So it's 2.890.
2.890 is 466.
Oh, 2.89.
Here we go.
And then it would be joules.
Capital J.
Okay, so let's see. 2.89. Using specific heat capacity to find temperature change.
Okay.
Well, this looks complicated. So that's our original.
Mm-hmm.
And we're trying to find change. So you would divide both sides by.
Okay, but look. This one's a little different. They're saying, let's see, a chemical reaction takes place inside of a flask submerged in a water bath. The water bath contains the 2.80 kilograms and of water at 33.5 degrees Celsius. So that's the initial temperature. During the reaction, 97.5 kilojoules of heat flows out of the bath and into the flask. Calculate the new temperature of the water bath. So they gave you initial temperature, they want you to find final temperature. And we can do that by solving for the change in temperature and then either minusing it or adding it to the initial temperature, depending on what happened. Because we read
So
through that.
It went up, right? No.
Let's see,
Oh, we don't know.
so heat flows out of the bath and into the flask. What's the
So
new
that means it went
temperature?
down.
Yeah, well, heat flew out of the bath, so the bath got cooler. So when we find out our change in temperature, we'll then minus it from, like, let's see, temperature initial minus our change in temperature equals the temperature final. Because it got colder. Okay, so we have our Q equals MC delta T. Need to arrange it, so we're solving for delta T first before we add any numbers.
So do you divide by mass and
Yep,
MC?
because you divide both sides by it.
By MC.
Mhm.
So it would be delta T equals Q divided by, I always forget what C is.
Specific heat.
Specific heat.
Heat capacity.
Okay. Q is heat, M is mass, C is specific heat, and then delta T is change. Okay.
Mhm.
So this is our new equation.
So what's heat? What's our number for heat?
Which one would we?
So what's the units for heat?
Joules.
Yes, they're joules.
But it gives us kilojoules.
Yeah, so what's our number for kilojoules?
So we need to change 97.5. So we need to change that.
Mm-hmm. Pick it fence.
Kilojoules.
1 by the kilojoule. And what's kilo mean?
10 to the third.
Mm-hmm. You just do that. And that will give you your number for the top. You can put it in your calculator if you want.
97.5 times 10 to the third. So it's 97,500. Joules.
Mhm.
Joules. Divided by mass. Mass is 2.80 kilograms. So we have to change
Kilograms,
that to,
yeah. So what was the number?
2.80.
Picket fence.
It's the same. 10 to the third.
Mhm.
So we do that as well. 2.80 times 10 to the third. 2,800. 2,800 grams.
Okay.
Okay, and then times what? Times
Specific heat
specific heat.
or heat capacity.
There's one more number, so I'm guessing that's the specific heat. 33.5.
That's degrees Celsius. Look in your second paragraph. The specific heat capacity is.
Oh, it's
Yeah.
specific heat capacity, 4.18 joules.
Joules over grams times by. Okay.
What does that mean again? Joules over grams times K.
So how many joules it takes to raise 1 gram, that many, takes 4.18 joules to raise 1 gram, 1 degree Kelvin.
Okay. So that's what we were figuring out before, but now they give it to us.
So joules divided by joules cancels,
Cancels out.
grams divided by grams, and then that becomes 1 over K. Algebraically it becomes K.
And
So
that's
like-
what we,
But we're solving for it. Yep. So then what's the answer?
what they want Celsius.
Remember the change in Kelvin is the same in change of Celsius?
Oh, yeah.
So that could be Celsius for specific heat. I think that's the only time you can do it. Yeah.
So then you just solve it.
Mm-hmm.
So you do 97,500 9,700 divided by. I make 2 parentheses to do the bottom, or just 1?
Yeah.
So it'll come
Oops.
out.
Over 2800 times by 4.
2,800 times 4.1. So it gives me, and we need 3 significant digits, so it's 8.33.
For the change in temperature. So that is how much, this is how much the temperature changed when the heat left the bath.
Okay.
So now, what was our initial temperature?
Initial was 33.5. So you do 33.5 minus 8.33.
Yep.
33.5 minus 8.33. Oh, and that's why you said that it doesn't matter that it's Kelvin, because the change is the same.
Yeah.
It's equal. So we didn't have to know like a specific number in Kelvin. That's why we didn't need to change.
Because if we converted the number to Kelvin, it would be the same. Because
Okay,
to both numbers,
So
yeah.
it's 25.72.
How many sig figs can keep?
Oh, 3. So it's 25.2 degrees Celsius. 25.2 degrees Celsius. Yep, Alex likes it.
That make more sense? So you have to read the equation. Sometimes it say heat flows out of the flask into the bath, or it might flow from out of the bath into the flask. So you have to see where the heat is going.
And that would,
Determine if we minus the
There's
change in
or
temperature
add.
or add it.
okay.
It's the heat. I guess you kind of think of it, they might put like a flask of ice water into a, hot bath, and yes, the bath will get colder and the flask will get warmer. You kind of think of it.
Because you just kind of like
Yeah,
picture the
heat
problem.
flows out of the bath, we know it gets cooler.
So it's minus.
Yeah, if heat flows out of the flask, we know that heat went into the bath, so it would get warmer. So just read the equation to see, okay, do I add it or do I subtract it?